Graphing Systems of Linear Equations
by Katelyn Blankoff.
In a linear system, you find the x and y coordinates that will make both equations true.
The solution of a linear system is the order pair that satisfies both equations.
To solve a system of linear equations graphically. Step 1. Put both equations in y equals mx plus b form. Step 2. Graph the lines. The point of intersection of the two lines is the solution of the systems. Step 3. Check algebraically. Make sure you check both equations.
3 possibilities for solutions.
The lines intersect at one point and have one unique solution. This is an independent system.
The second possible solution is the lines are parallel and have no solution. This is an inconsistent system. Parallel lines have the same slope. The third possibility is there are two equations for the same line. The two equations overlap. They have an infinite number of solutions.
This is a dependent system.
An example. Graph the system of equations, state the coordinates of the points in the solution set, and check. First, you have to find the y-intercept. The y-intercept of this equation is the coordinate 0, 2. Next, you find the slope. The slope is the coefficient in front of x. The slope for this equation is 1 over 1, up 1 to the right 1. Label your axes. X is on the horizontal line and y is on the vertical line. Now, plot your first point, which is the y-intercept, 0, 2. Continue plotting your points using the slope, up 1 to the right 1. Continue doing this until you can't fit anymore. Connect the coordinates with a line going across. Since the line will continue on forever, put arrows at the end. Label the line f of x equals x plus 2. For the next equation, you first find the y-intercept. The y-intercept of this equation is the coordinate 0, 8. Next, you find the slope, which is the coefficient in front of x, which is negative 2. Negative 2 over 1, which means down 2 to the right 1. First, plot the y-intercept, 0, 8. Then, using your slope, plot the rest of the points. Go down 2 to the right 1. Continue this until you can't fit any more points. Put a line through the points. And remember to put arrows to represent the line will go on forever. Label the line g of x equals negative 2x plus 8. The solution of this graph is where the two lines intercept, which is the coordinate 2, 4. This is an independent system since both lines overlap. Now you're going to check to make sure the solution is 2, 4. Plug 2 for x and plug 4 for y. 2 plus 2 is 4. 4 equals 4. The first equation works. For the next equation, once again, plug 2 for x and 4 for y. Negative 2 times 2 plus 8 equals 4. 4 equals 4 and both sides are equal. This equation worked out. Both equations are equal on both sides, therefore the solution is 2, 4. The solution is 2, 4.
I am Annelisa. Solving systems of equations elimination method. Step 1. Add or subtract to eliminate one variable. Remember, you add additive inverses. An example is negative 2x and 2x. You subtract same. An example is 3x and 3x. Step 2. Solve for the remaining variable. Step 3. Plug your solution into one of the original equations to solve for the other variable. Step 4. State the solution. Remember, when you graph the two equations, the solution is the point of intersection. Step 5. Check. Rewrite, replace, recalculate. Example 1. The first step is to add, which eliminates both of the y's, so 3x equals 30. Then you solve for the remaining variable by dividing by 3, so x equals 10. Then you plug in the solution in one of the original equations to solve for the other variable. To isolate the variable, subtract 10 from both sides. This gives you negative y equals 1. Separate the variable from the coefficient by dividing by negative 1. 1 divided by negative 1 is negative 1, so y equals negative 1. The solution is written in form of an ordered pair, 10, negative 1. Remember that x comes first and y comes second in alphabetical order. To check, first rewrite one of the original equations. Then plug in your solution for x and y. Solve the equation. If both sides of the equation are equal, then your solution is correct. Example 2. You would subtract to eliminate the negative 9y and the negative 9y. This would give you 2x equals negative 2. Then you solve for the remaining variable by dividing by 2, so x equals negative 1. Then you plug in the solution to x in one of the original equations to solve for the other variable. To isolate the variable, first you have to simplify the equation, which gives you 2 minus 9y equals negative 25. Then subtract 2 from each side. This gives you negative 9y equals negative 27. To separate the coefficient from the variable, divide by negative 9. Negative 27 divided by negative 9 is 3, so y equals 3. The solution is written in the form of an ordered pair, negative 1, 3. Remember that x comes first and y comes second in alphabetical order. To check, first rewrite one of the original equations. Then plug in your solutions for x and y. Solve the equation. If both sides of the equation are equal, then your solution is correct.